What's up, gals and pals? Welcome to Mindful Math. Today we're going to talk about how to graph a line using any of the various forms that our equation can come in. So most of us are much more comfortable graphing a line in slope-intercept form than we are in point-slope form, or heaven forbid, in standard form. Why that's called standard form is absolutely beyond me. Maybe you can give me a good reason why that's called standard form, but these forms are certainly much more useful in terms of graphing than that standard form is. But this method we can use for any of the forms, and hopefully this will allow you to see how and why we can graph lines using these other two forms better, what information we're given right away. So the method that I'm going to talk about today is just picking 2 points on the line and then connecting the line and extrapolating it out. So how do we go about picking a point on the line? Well, since we know that any line is going to have every y value and every x value at some point, unless it's a vertical line, we can go ahead and just pick arbitrary values for x or y. So in other words, we can pick whatever value we want for x or y, and then we can tell where the other variable is on that line. So for example, in this first equation, we're in slope-intercept form, but let's just go ahead and say, well, where is y when x equals 0? Well, when x is 0, y is going to be at 3. So we know that the point 0, 3 has to lie on that line. And in fact, when you graph lines in slope-intercept form using the intercept and then using the slope, that's all you're really doing. Essentially, you're taking that x equals 0 value to give you the y-intercept. The y-intercept is nothing more than where y is when x equals 0. So now we need one more point, and so let's go ahead and find out where y is when x equals 1. When x equals 1, we have -2 plus 3, and so y will also be 1. And now that we have those 2 points, we can draw a line like I did, just an absolutely beautiful line, as you can tell, very straight. There's a reason I went into math and not art, but anyway, I thought I got away with it, but turns out you need art even in math. So this method can be used for any of these forms. Probably you're comfortable using slope-intercept form anyway, and you don't need this method, but hopefully it allows you to see a different way of doing it and why our slope-intercept form works. As you can tell, if you had done it the normal way, or the way you're more used to most likely, you would have found the y-intercept at 3, then you would have gone over 1 and down 2, and you would have gotten the exact same point that I did. So again, we want to pick numbers that make it easy for us to calculate. There's no reason to pick a number like 18 over 3. Certainly we could do that. 18 over 3 is just 6. Anyway, 18 over 5, certainly we could pick that, but it's going to make our calculations a lot more difficult. So 0 and 1 are often going to be our friends, but we want to stay mindful because sometimes it actually will be easier to pick slightly different numbers, as we'll see in a little bit. All right, in this second equation, we have the equation of a line in point-slope form. We just had slope-intercept. So here we have it in point-slope form, and I don't know about you, but I still sometimes go back to that slope-intercept form, and that's just because we learn this so much. It's so ingrained in us how to do that. But you should try to learn how to graph straight from slope-intercept. I keep messing this up. I'm so ingrained with slope-intercept that I can't even remember the name of the form. You should try to learn how to graph a line in point-slope form in a similar way to how you did it in slope-intercept form. So you are given the slope and you are given a point, so you can go ahead and do that directly, but in case you get stuck, let's go ahead and see what happens if we use that method of just finding 2 points. So again, I'm going to pick x equals 0 because I think that's the easiest thing to calculate. So if x is 0, we have 2 on this side, 2 times 1 is 2, and we're going to solve for y. We're going to add 1 to both sides, and we'll get that y equals 3. So we have that point at 0, 3, which is the same point that we had on the previous line. And then we're going to go ahead and pick another number for x. So in this case, let's go ahead and pick x equals 1, because I think that's a pretty easy calculation to do. If x is 1, we've got 2 in the middle here. 2 times 2 is 4. We've got 4 on this side, we add 1, we get that y equals 5. When x equals 1, we have our 2 points, and again we can draw a beautiful, beautiful straight line because we are all artists. So again, if you can graph it straight from point slope form, that's great. If you get stuck or if you're not sure, this is another way that you can do it. And hopefully, again, you're seeing the connections between them. So go ahead and write in the comments below how you can see why this method works and why the other methods that we teach work. Why we can just go from that y-intercept and go, in this case, down to and over to the right one or up to and over to the left one, and how we can do a similar thing there. All right, our favorite form, the standard form. Maybe it's called standard form because it's standardized tests. Standardized tests are certainly pretty terrible most of the time, so maybe this is standard form because it's used to torture us, just like standardized tests, right? All right, so when we're given an equation in standard form, this is when I find this method most useful. Certainly you could solve for x or solve for y or put it into point slope form. Any of those methods certainly work, but if you want to avoid doing algebra with variables, this method works really well. So in the last two cases, we picked a number for x. We actually can pick a number for y as well. And let's go ahead and do that here, and hopefully you see why I want to do that. We have 4 on this side, and the number in front of the y, that coefficient, is a 3. And 3 doesn't divide evenly into 4. So if I can get rid of that y and not have to do that kind of math, then I'm much better off, and it's going to be much easier to solve for x than it would be to solve for y. So again, 0 is our friend in these equations. So let's go ahead and find out what happens when y equals 0. So when y equals 0, that whole term cancels out. We just have 2x equals 4, and so x equals 2. And so we can go ahead and plot that point. Make sure that you don't have it backwards, so when you do choose a y, make sure to be very careful about how you write your point. So it is 2, 0. So let's go ahead and plot that point, and that is the x-intercept, 2, 0. So again, it is, I think, easier to pick a number for y. We could certainly pick a number for x, any number but 2, just because that would give us the same point again. But we can also pick another number for y. And in this case, I'm going to pick 4. And the reason I want to pick 4 is because that's going to help us in our calculations. So when y is 4, this is going to be 12, and that's going to give me a more even number when I subtract it from 4. So we'll have 12 plus 2x equals 4, and if we subtract 12 from both sides, we'll get that 2x equals -8, and that x equals -4. So I'm going to go ahead and erase that so I can plot my point. But when x is -4, y is +4, and we can go ahead and graph, again, our beautiful straight line, because we're all artists in math class. So I hope you found this method helpful. Again, this can be used on any form of any equation. You're probably going to want to use your normal methods, the methods that you've probably overlearned by now for slope-intercept form, but this is particularly helpful when we're given that in standard form and we don't want to do algebra. So if you have any questions about this, please feel free to post in the comments below, and we'll see you next time.